Imagine pointing a small backyard telescope toward the night sky, expecting nothing more than a faint smudge drifting between the stars, and instead finding something NASA barely mentioned in their own press conference. Something so bright, so oversized, and so chemically strange that it forces us to rethink what we thought we knew about interstellar visitors. While the world listened to the official, careful version of events, an independent astrophotographer named Ray was pulling in raw, unfiltered data from his own modest equipment. And what he captured wasn't just different from NASA's highlights. It revealed everything they didn't emphasize, everything they brushed past, or everything they didn't want to complicate the story with. A 400-fold brightness explosion, a dramatic color shift, a coma larger than Earth itself, and an upcoming encounter with Jupiter that only a handful of comets in all recorded history have ever survived. Ray starts his video calmly, almost casually, saying that NASA missed a lot of stuff about 3I Atlas. But once you dig into his findings, you realize how much of an understatement that is. Because what he found wasn't a small error or a minor oversight. It was foundation-shaking evidence of an interstellar object behaving in ways that standard comet models can't neatly explain. Ray is not a government lab or a billion-dollar observatory. He's just a person with a telescope, a suburban sky, and the curiosity to notice when something doesn't add up. And this is exactly why his discovery hits so hard. Sometimes the biggest breakthroughs don't come from institutions. They come from people who are simply paying attention. Ray retraces the path of 3I Atlas and calculates that it probably entered our solar system around 2017, silently drifting through the outer regions before becoming visible in 2025. This isn't just another icy rock following a predictable orbit. This is a hyperbolic visitor from another star system, a relic that formed around a completely different sun billions of years ago. When it reached perihelion, NASA's stereo satellite captured something incredible, yet somehow barely highlighted in the press conference. A brightness surge so intense it dwarfed anything we normally see from comets. Ray points out that NASA mentioned it quietly, almost as if it were nothing unusual, but this level of brightening is anything but normal. 3I Atlas became about 400 times brighter than a typical comet. Even unusually active comets rarely show this kind of energy release. NASA listed it as a fun fact. Ray treats it like the major scientific event it truly is. Because comets do brighten near the sun, but they don't explode with energy like cosmic flashbulbs. If anything deserved center stage in NASA's announcement, it was this. Then Ray highlights something even stranger. The comet didn't just brighten, it changed color. It shifted from red to blue while skipping the entire green range, something that is not typical for comet chemistry. Usually, color transitions are gradual and occupy predictable wavelengths, but 3I Atlas acted like a system with entirely different chemistry. Ray believes this color shift may be one of the comet's most important clues. Because spectra reveal chemical fingerprints, and fingerprints reveal where something was born. If this object formed around a different star, its chemistry should reflect that. NASA mentioned none of this with the weight it deserved. After passing its closest point to the Sun, the comet continued toward Mars. NASA released a blurry, low-quality MRO image that immediately triggered online backlash. But Ray argues the real missed opportunity wasn't Mars at all. It was something in Earth orbit. SpaceX's Punch satellites, launched in 2025 to map the solar wind, captured incredibly detailed images of the comet from only 600 kilometers above Earth. Yet NASA did not feature these images in their presentation. In Ray's video, he shows them clearly, and they are stunning. The coma of 3I Atlas is roughly 17,000 kilometers across, making it larger than Earth. These images even captured Mars drifting across the view while 3I Atlas appeared above it like a glowing giant. From low Earth orbit, the comet looks enormous. From Mars, Ray says, it would have dominated the sky. Ray emphasizes that this should have been a defining moment in NASA's communication, showing the public a comet larger than Earth's diameter, glowing next to Mars in a single frame. Instead, the images were quietly uploaded after the fact. Not hidden, just underplayed. But the impact they could have had is enormous. Ray continues analyzing the comet's development, pointing out that the huge brightness surge doesn't just come from chemistry. It comes from sheer physical size. 3I Atlas is one of the largest dynamically active comets ever recorded, and the interstellar origin makes it a treasure for scientists. Its dust, its gases, its minerals, all of it formed around a different sun. Studying this object is like studying the geological DNA of another planetary system. Ray also addresses an important misconception floating around online. Many people say the comet is simply passing near Jupiter, but that doesn't capture the truth. Passing through Jupiter's Hill sphere is common. But passing extremely close to Jupiter itself, close enough for its gravity to potentially tear the comet apart, is incredibly rare. Only a few comets in history have ever done so and survived. 3I Atlas is heading directly into this region, and Ray brings attention to this far more clearly than NASA did. This is not a routine orbit. This is a gravitational trial that could rewrite the comet's future or end its journey entirely. Ray also notices something unusual in his own images. When he removes the background stars, the central region of the coma appears pointed, almost like a faint triangular or directional structure. He isn't claiming he can see the nucleus, no telescope today can resolve that. But he is showing real structure in the dust escaping from it. And when he compares his processed images with older Hubble data, the pointed shape appears in both. That validation proves the feature is real, not a processing glitch. It also proves that independent astrophotographers can contribute to scientific understanding in meaningful ways. As 3I Atlas gets closer to Earth, Ray continues to observe the comet night after night. And as he does, the internal shape becomes more visible. What began as a uniform blur is gradually showing layers, directionality, and a rhythmic pattern that might be caused by rotation. None of this breaks known science, but seeing it so clearly from a backyard telescope shows just how active and unusual this comet is. Ray keeps reminding viewers that this moment is unique not just in our lifetimes, but in human history. JWST and Hubble can't resolve the nucleus, and the next generation of giant telescopes won't be ready until long after the comet has left the solar system forever. Every image captured today, whether by NASA or by Ray, represents a tiny fragment of a disappearing opportunity. Ray's message isn't that NASA is wrong. It's that institutional communication often filters out the very details that make a discovery extraordinary. A brightness explosion that should have been headline news. A color shift that suggests alien chemistry. A coma bigger than Earth. A rare Jupiter encounter that only a few comets have ever survived. A pointed core visible in both Hubble and backyard images. All these details create a far more dramatic and meaningful story than the one presented officially. Ray shows that discovery no longer belongs only to giant agencies. It belongs to anyone curious enough to look up. Sometimes the truth isn't hidden, it's simply waiting for someone to notice. And in the case of 3I Atlas, that someone was a lone observer in his backyard capturing history before it disappears into the dark between stars.